Section 7 of National Geographic Magazine, Volume 1, Number 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Reading by Matt Perard. The Rivers and Valleys of Pennsylvania, Part 4, by William Morris Davis, 1850 to 1934. Evidence of superimposition in the Susquehanna tributaries. One of the peculiarities of floodplain rivers is that the lateral streams shift their points of union with the main stream farther and farther down the valley, as Lombardini has shown in the case of the Po. If the Susquehanna were heavily floodplained at the close of the Jura-Cretaceous cycle, some of its tributaries should manifest signs of this kind of deflection from their structural courses along the strike of the rocks. Side streams that once joined the main stream on the line of some of the softer northeast-southwest beds, leaving the stronger beds as faint hills on either side, must have forgotten such control after it was baseleveled and buried. As the flood plain grew, they properly took more and more distinctly downward deflected courses, and these deflections should be maintained in subsequent cycles as superimposed courses independent of structural guidance. Such I believe to be the fact. The downstream deflection is so distinctly a peculiarity of a number of tributaries that join the Susquehanna on the west side, that it cannot be ascribed to accident, but must be returned to some systematic cause. Examples of deflection are found in Peon's Creek, Middle Creek, and North Mahantango Creek in Snyder County, West Mahantango between the latter and Juniata County, and in the Juniata and Little Juniata rivers of Perry County. On the other side of the Susquehanna, the examples are not so distinct, but the following may be mentioned: Delaware and Warrior Runs, Chillisquaque Creek, and Little Shamokin Creek, all in Northumberland County. It may be remarked that it does not seem impossible that the reason for the more distinct deflection of the western streams may be that the Susquehanna is at present east of its old course, and hence towards the eastern margin of its flood plain, as, indeed, its position on the Pocono synclinals implies. A reason for the final location of the superimposed river on the eastern side of the old flood plain may perhaps be found in the eastward tilting that is known to have accompanied the elevation of the Cretaceous lowland. It follows from the foregoing that the present lower course of the Susquehanna must also be of superimposed origin, for the flood plain of the middle course must have extended downstream to its delta, and there have become confluent with the sheet of Cretaceous sediments that covered all the southeastern lowland, over which the sea had transgressed. McGee has already pointed out indications of superimposed stream courses in the southeastern part of the state, but I am not sure that he would regard them as of the date here referred to. The theory of the location of the Susquehanna on the Pocono synclinal ridges therefore stands as follows. The general position of the river indicates that it has been located by some process of slow self-adjusting development, and that it is not a persistent antecedent river, and yet there is no reason to think that it could have been brought into its present special position by any process of shifting divides. The processes that have been suggested to account for its special location as departing slightly from a location due to slow adjustments following an ancient consequent origin call for the occurrence of certain additional peculiarities in the courses of its tributary streams, entirely unforeseen and unnoticed until this point in the inquiry is reached, and on looking at the map to see if they occur, they are found with perfect distinctness. The hypothesis of superimposition may therefore be regarded as having advanced beyond the stage of mere suggestion and as having gained some degree of confirmation from the congealations that it detects and explains. It only remains to ask if these correlations might have originated in any other way, and if the answer to this is in the negative, the case may be looked upon as having a fair measure of evidence in its favor. The remaining consideration may be taken up at once as the first point to be examined, in the Tertiary cycle of development. 37. Events of the Tertiary cycle. The elevation given to the region by which Cretaceous basal veiling was terminated, and which I have called the early Tertiary elevation, offered opportunity for the streams to deepen their channels once more. In doing so, certain adjustments of moderate amount occurred, which will be soon examined. As time went on, much denudation was effected, but no widespread baseleveling was reached, for the Cretaceous crest lines of the hard sandstone ridges still exist. The Tertiary cycle was an incomplete one. At its close, lowlands had been opened only on the weaker rocks between the hard beds. Is it not possible that the floodplaning of the Susquehanna and the downstream deflection of its branches took place in the closing stages of this cycle, instead of at the end of the previous cycle? If so, the deflection might appear on the branches, but the main river would not be transferred to the Pocono ridges. This question may be safely answered in the negative, for the Tertiary lowland is by no means well enough baseleveled to permit such an event. The beds of intermediate resistance, the Oriskany and certain Chemung sandstones, had not been worn down to baselevel at the close of the Tertiary cycle. They had indeed lost much of the height that they possessed at the close of the previous cycle, but they had not been reduced as low as the softer beds on either side. They were only reduced to ridges of moderate and unequal height over the general plain of the Siluro-Devonian low country, without great strength of relief, but quite strong enough to call for obedience from the streams alongside of them. And yet near Selin's Grove, for example, in Snyder County, Penn's and Middle creeks depart most distinctly from the strike of the local rocks as they near the Susquehanna, and traverse certain well-marked ridges on their way to the main river. Such aberrant streams cannot be regarded as superimposed at the close of the incomplete Tertiary cycle. They cannot be explained by any process of spontaneous adjustment yet described. Nor can they be regarded as vastly ancient streams of antecedent courses. I am therefore much tempted to consider them as of superimposed origin, inheriting their present courses from the floodplain cover of the Susquehanna in the latest stage of the Jura-Cretaceous cycle. With this tentative conclusion in mind as to the final events of the Jura-Cretaceous time, we may take up the more deliberate consideration of the work of the Tertiary cycle. The chief work of the Tertiary cycle was merely the opening of the valley lowlands. Little opportunity for river adjustment occurred except on a small scale. The most evident cases of adjustment have resulted in the change of water gaps into wind gaps, of which several examples can be given, the one best known being the Delaware wind gap between the Lehigh and Delaware water gaps in Blue Mountain. The wind gap marks the unfinished notch of some stream that once crossed the ridge here, and whose headwaters have since then been diverted, probably to the Lehigh. The difficulty in the case is not at all how the stream that once flowed here was diverted, but how a stream that could be diverted in the Tertiary cycle could have escaped diversion at some earlier date. The relative rarity of wind gaps indicates that nearly all of the initial lateral streams which may have crossed the ridges at an early epoch in the history of the rivers have been beheaded in some cycle earlier than the Tertiary and their gaps thereafter obliterated. Why the Delaware wind gap stream should have endured into a later cycle does not at present appear. Other wind gaps of apparently similar origin may be found in Blue Mountain west of the Schuylkill and east of the Susquehanna. It is noteworthy that if any small streams still persevere in their gaps across a hard ridge, they are not very close to any large river gap. Hence, it is only at the very headwaters of Conedogwinet Creek in the northern part of Franklin County that any water is still drawn from the back of Blue Mountain. Again, these small stream gaps do not lie between large river gaps and wind gaps, but wind gaps lie between the gaps of large rivers and those of small streams that are not yet diverted. Excellent illustration of this is found on the Piedmont sheet of the contoured maps issued by the United States Geological Survey. The sheet covers part of Maryland and West Virginia, near where the north branch of the Potomac comes out of the plateau and crosses New Creek Mountain. 11 miles south of the Potomac Gap there is a deep wind gap, but further on, at 20, 25, and 29 miles from the river gap are 3 fine water gaps, occupied by small streams. This example merely shows how many important points in the history of our rivers will be made clear when the country is properly portrayed on contoured maps. A few lines may be given to the general absence of gaps in Blue Mountain in Pennsylvania. When the initial consequent drainage was established, many streams must have been located on the northward slope of the great Cumberland highland. They must have gullied the slope to great depths and carried away great volumes of the weak Cambrian beds that lay deep within the hard outer casings of the mass. Minor adjustments served to diminish the number of these streams, but the more effective cause of their present rarity lay in the natural selection of certain of them to become large streams. The smaller ones were generally beheaded by these. The only examples of streams that still cross the ridge with their initial Permian direction of flow to the northwest are found in 2 southern branches of Tuscarora Creek at the southern point of Juniata County, and these survive because of their obscure location among the many Medina ridges of that district, where they were not easily accessible to capture by other streams. 38. Tertiary adjustment of the Juniata on the Medina anticlines. The lower course of the Juniata presents several examples of adjustment referable to the last part of the Jura Cretaceous cycle and to the Tertiary cycle. The explanation offered for the escape of this river from its initial syncline did not show any reason for its peculiar position with respect to the several Medina anticlines that it now borders, because at the time when it was led across country to the Wiconisco syncline, the hard Medina beds of these anticlines were not discovered. It is therefore hardly to be thought that the location of the Juniata in the narrows below Lewistown, between Blue Ridge and Shade Mountain, and its avoidance of Tuscarora Mountain could have been defined at that early date. But all these Medina anticlines rise more or less above the Cretaceous baselevel and must have had some effect on the position taken by the river about the middle of that cycle, when its channel sank upon them. Blue Ridge and Black Log anticlines rise highest. The first location of the cross-country stream that led the early Juniata away from its initial syncline probably traversed the Blue Ridge and Black Log anticlines when they were yet buried, but its channel cutting was much retarded on encountering them, and some branch stream working around from the lower side of the obstructions may have diverted the river to an easier path. The only path of the kind is the narrow one between the overlapping anticlines of Blue Ridge and Shade Mountains, and there the Juniata now flows. If another elevation should occur in the future, it might happen that the slow deepening of the channel in the hard Medina beds which now floor the narrows would allow Middle Creek of Snyder County to tap the Juniata at Lewistown and lead it by direct course past Middleburg to the Susquehanna. Thus it would return to the path of its youth. The location of the Juniata at the end of Tuscarora mountain is again so definite that it can hardly be referred to a time when the mountain had not been revealed. The most likely position of the original cross country stream which brought the Juniata into the Wiconisco syncline was somewhere on the line of the existing mountain, and assuming it to have been there, we must question how it has been displaced. The process seems to have been of the same kind as that just given, the retardation of channel cutting in the late Cretaceous cycle, when the Medina beds of Tuscarora anticline were discovered, allowed a branch from the lower part of the river to work around the end of the mountain and lead the river out that way. The occurrence of a shallow depression across the summit of the otherwise remarkably even crest of Tuscarora mountain suggests that this diversion was not finally accomplished until shortly after the Tertiary elevation of the country. But at whatever date the adjustment occurred, it is natural that it should pass around the eastern end of the mountain and not around the western end, where the course would have been much longer, and therefore not successfully to be taken by a diverting stream. While the quality of these processes appears satisfactory, I am not satisfied as to the sufficiency of their quantity. If diversion was successfully practiced at the crossing of the Tuscarora anticline, why not also at the crossing of Jack's Mountain anticline, on which the river still perseveres? It is difficult here to decide how much confidence may be placed in the explanation, because of its giving reason for the location of certain streams, and how much doubt must be cast upon it, because it seems impossible and is not of universal application. 39. Migration of the Atlantic—Ohio divide. There are certain shifted courses which cannot be definitely referred to any particular cycle, and which may therefore be mentioned now. Among the greatest are those by which the divide between the Atlantic and the Ohio streams has been changed from its initial position on the great constructional Nittany highland and Bedford range. There was probably no significant change till after Newark depression, for the branches of the Anthracite river could not have begun to push the divide westward till after the eastward flow of the river was determined. Until then there does not seem to have been any marked advantage possessed by the eastward streams over the westward. But with the eastward escape of the Anthracite, it probably found a shorter course to the sea and one that led it over alternately soft and hard rocks, instead of the longer course followed by the Ohio streams over continuous sandstones. The advantage given by the greater extent of soft beds is indicated by the great breadth of the existing valleys in the central district compared with the less breadth of those in the plateau to the west. Consider the effect of this advantage at the time of the Jurassic elevation. As the streams on the eastern slope of Nittany divide had the shortest and steepest courses to the sea, they deepened their valleys faster than those on the west and acquired drainage area from them. Hence we find reason for the drainage of the entire Nittany and Bedford district by the Atlantic streams at present. Various branches of what are now the Alleghany and Monongahela originally rose on the western slope of the dividing range. These probably reached much farther east of pre-Permian time, but had their headwaters turned another way by the growth of the great anticlinal divide. But the smaller anticlines of Laurel Ridge and Negro Mountain farther west do not seem to have been strong enough to form a divide, for the rivers still traverse them. Now, as the headwaters of the Juniata breached the eastern slope of the Nittany Bedford range and pushed the divide westward, they at last gained possession of the Siluro Devonian monocline on its western slope. But beyond this it has not been possible for them yet to go. As the streams cut down deeper and encountered the Medina anticline near the core of the ridge, they sought a passage through it. The Cambrian beds were discovered below and a valley was opened on them as the Medina cover wore away. The most important point about this is that we find in it an adequate explanation of the opposite location of water gaps in pairs, such as characterize the branches of the Juniata below Tyrone and again below Bedford. This opposite location has been held to indicate an antecedent origin of the river that passes through the gaps, while gaps formed by self-developed streams are not yet thought to present such correspondence. Hyber. Yet this special case of paired gaps in the opposite walls of a breached anticline is manifestly a direct sequence of the development of the Juniata headwaters. The settling down of the main Juniata on Jack's Mountain anticline below Huntingdon is another case of the same kind, in which the relatively low anticlinal crest is as yet not widely breached. The gaps below Bedford stand apart, as the crest is there higher, and hence wider opened, and the gaps below Tyrone are separated by some 10 or 12 miles. When the headwater streams captured the drainage of the Siluro Devonian monocline on the western side of the ancient dividing anticline, they developed subsequent rectangular branches growing like a well-trained grapevine. Most of this valley had been acquired by the west branch of the Susquehanna, probably because it traversed the Medina beds less often than the Juniata. For the same reason, it may be, the west branch has captured a considerable area of plateau drainage that must have once belonged to the Ohio, while the Juniata has none of it. But if so, the capture must have been before the Tertiary cycle, for since that time the ability of the west branch and of the Juniata as regards such capture appears about alike. On the other hand, Castleman's River, a branch of the Monongahela, still retains the drainage of a small bit of the Siluro Devonian monocline at the southern border of the state, where the Juniata headwaters had the least opportunity to capture it. But the change here is probably only retarded, not prevented entirely. The Juniata will some day push the divide even here back to the Allegheny front, the frontal bluff of the plateau. 40. Other examples of adjustments. Other examples of small adjustments are found around the Wyoming basin. Originally, all these streams ran centripetally down the enclosing slopes, and in such locations they must have cut gullies and breaches in the hard carboniferous beds, and opened low back country on the weaker Devonians. Some of the existing streams still do so, and these are precisely the ones that are not easily reached by divertors. The Susquehanna, in its course outside of the basin, has sent out branches that have beheaded all these centripetal streams within reach. Where the same river enters the basin, these centripetal streams have been shortened, if not completely beheaded. A branch of the Delaware has captured the heads of some of the streams near the eastern end of the basin. Elsewhere, the centripetal streams still exist of good length. The contrast between the persistence of some of the centripetal streams here and their peripheral diversion around Broad Top is a consequence of the difference of altitude of the old lake bottoms in the two cases. It is not to be doubted that we shall become acquainted with many examples of this kind as our intimacy with rivers increases. 41. Events of the Quaternary cycle. The brief Quaternary cycle does not offer many examples of the kind that we have considered, and all that are found are of small dimensions. The only capturing stream that need be mentioned has lately been described as a river pirate, but its conquest is only a Schleswig-Holstein affair compared to the Goth and Hun-like depredations of the greater streams in earlier cycles. The character of the streams and their valleys as they now exist is strikingly dependent in many ways on the relation of the incipient Quaternary cycle to the longer cycles of the past. no lakes occur, exception being made only of the relatively small ponds due to drift obstruction within the glaciated area. Waterfalls are found only at the headwaters of small streams in the plateau district, exception again being made only for certain cases of larger streams that have been thrown from their preglacial courses by drift barriers and which are now in a very immature state on their new lines of flow. The small valleys of this cycle are shallow and narrow, always of a size strictly proportional to the volume of the stream and the hardness of the enclosing rocks, exception being made only in the case of post-glacial gorges whose streams have been displaced from their preglacial channels. The terraces that are seen, especially on the streams that flow in or from the glaciated district, are merely a temporary and subordinate complication of the general development of the valleys. In the region that has been here considered, the streams have been seldom much displaced from their preglacial channels, but in the northwestern part of the state, where the drift in the valleys seems to be heavier, more serious disturbance of preglacial courses is reported. The facts here referred to in regard to lakes, falls, gorges, terraces, and displaced streams are to be found in the various volumes of the Second Geological Survey of the state. In regard to the terraces and the estuarine deflections of the Delaware and Susquehanna, reference should be made also to McGee's studies. 42. Doubtful cases. It is hardly necessary to state that there are many facts for which no satisfactory explanation is found under the theory of adjustments that we have been considering. Some will certainly include the location of the Susquehanna on the points of the Pocono synclines under this category. All must feel that such a location savors of an antecedent origin. The same is true of the examples of the alignment of water gaps found on certain streams. For example, the 4 gaps cut in the 2 pairs of Pocono and Pottsville outcrops at the west end of the Wyoming syncline, and the 3 gaps where the Little Schuylkill crosses the coal basin at Tamaqua. The opposite gaps in pairs at Tyrone and Bedford have already been sufficiently explained. The location of the upper north branch of the Susquehanna is also unrelated to processes of adjustment as far as I can see them, and the great plain of plateau drainage that is now possessed by the west branch is certainly difficult to understand as the result of conquest. The 2 independent gaps in Tussey's Mountain, maintained by the Juniata and its Frankstown branch below Tyrone, are curious, especially in view of the apparent diversion of the branch to the main stream on the upper side of Warrior's Ridge, or Sky, just east of Tussey's Mountain. 43. Complicated history of our actual rivers. If this theory of the history of our rivers is correct, it follows that any one river as it now exists is of so complicated an origin that its development cannot become a matter of general study and must unhappily remain only a subject for special investigation for some time to come. It was my hope on beginning this essay to find some teachable sequence of facts that would serve to relieve the usual routine of statistical and descriptive geography, but this is not the result that has been attained. The history of the Susquehanna, the Juniata, or the Schuylkill is too involved with complex changes, if not enshrouded in mystery, to become intelligible to any but advanced students. Only the simplest cases of river development can be introduced into the narrow limits of ordinary instruction. The single course of an ancient stream is now broken into several independent parts. Witness the disjointing and diversion of the original Juniata, which, as I have supposed, once extended from Broad Top Lake to the Catawissa Basin. Now the upper part of the stream, representing the early Broad Top outlet, is reduced to small volume and Agwick Creek. The continuation of the stream to Lewistown is first set to one side of its original axial location and is then diverted to another syncline. The beheaded portion, now represented by Middle Creek, is diverted from its course to the Catawissa basin by the Susquehanna. Perhaps the Catawissa of the present day represents the reversed course of the lower Juniata where it joined the Anthracite. This unserviceably complicated statement is not much simplified if instead of beginning with an original stream and searching out its present disjointed parts, we trace the composition of a single existing stream from its once independent parts. The Juniata of today consists of headwaters acquired from Ohio streams. The lake in which the river once gathered its upper branches is now drained and the lake bottom has become a mountain top. The streams flow around the margin of the lake, not across its basin. A short course towards Lewistown nearly coincides with the original location of the stream. But to confound this with a precise agreement is to lose the true significance of river history. The lower course is the product of diversion, at least at two epochs and certainly in several places. Where the river now joins the Susquehanna, it is suspected of having a superimposed course unlike any of the rest of the stream. This is too complicated, even if it should ever be demonstrated to be wholly true, to serve as material for ordinary study. But as long as it has a savor of truth, and as long as we are ignorant of the whole history of our rivers, through which alone their present features can be rightfully understood, we must continue to search after the natural processes of their development as carefully and thoroughly as the biologist searches for the links missing from his scheme of classification. 44. Provisional conclusion. It is in view of these doubts and complications that I feel that the history of our rivers is not yet settled, but yet the numerous accordances of actual and deductive locations appear so definite, and in some cases so remarkable, that they cannot be neglected, as they must be if we should adhere to the antecedent origin of the river courses. The method adopted on an early page therefore seems to be justified. The provisional system of ancient consequent drainage, illustrated on Fig. 21, does appear to be sufficiently related to the streams of today to warrant the belief that most of our rivers took their first courses between the primitive folds of our mountains, and that from that distant time to the present the changes they have suffered are due to their own interaction, to their own mutual adjustment, more than to any other cause. The Susquehanna, Schuylkill, Lehigh, and Delaware are composite, and highly complex rivers of repeated mature adjustment. The middle Susquehanna and its branches and the upper portions of the Schuylkill and Lehigh are descendants of original Permian rivers consequent on the constructional topography of that time. Newark depression reversed the flow of some of the transverse streams, and the spontaneous changes of adjustments from immature to mature courses in the several cycles of development are so numerous and extensive that, as Lowell truly says, the initial drainage has almost disappeared. The larger westward flowing streams of the plateau are of earlier Carboniferous birth, and have suffered little subsequent change beyond a loss of headwaters. The lower courses of the Atlantic rivers are younger, having been much shifted from their Permian or pre-Permian courses by Newark and Cretaceous superimposition, as well as by recent downward deformation of the surface in their existing estuaries. No recognizable remnant of rivers antecedent to the Permian deformation are found in the central part of the State, and with the exception of parts of the upper Schuylkill and of the Susquehanna near Wilkes-Barre, there are no large survivors of Permian consequent streams in the ordinary meaning of the term consequent. The shifting of courses in the progress of mature adjustment has had more to do with determining the actual location of our rivers and streams than any other process. Harvard College, June, 1889. End of Section 7.